Hey folks, so Gavin Hill from the Advanced Manufacturing Research Centre in the UK. And my main focus is I look at the digital industry 4 style work and research that we're doing. I'm going to just take you through one project idea here, but fundamentally I've got a list of about 20 in my head. It's just trying to work out, who's here, what's applicable to your countries, to the organizations that you're working with, to the organizations that you are. So who are we as an AMRC? So we're a part of the University of Sheffield, but we're very, very tightly aligned to industry. So we've got about 121 industrial partners who are members of the organization, mainly focused in aerospace, but we do an awful lot more now in rail, automotive, construction and medical, space as well, probably another key area. And this is just me focusing on our key areas of work. So our core pillars are kind of very well aligned to what we've seen earlier on, but around sustainability, digitization. We've got future propulsion here with a little airplane, but that's more generically to all types of transport. And then into the supply chain side and how we map that out and try and make that a little bit more resilient. And then the areas that we focus on go the whole way through the, I suppose, the circular economy side of things. So we're going from everything from the high value design stage through into actually manufacturing parts and components, into kind of how we assemble them and put them all together in an automated way if we can, or by enhancing what a human operator is doing. Then looking at how we validate that and make sure that things have been done in the right way. And then looking at, right, when that product's out in the real world, how do we get data from it to understand, is it doing what it should do? How do we take that data and use that to feed into the next version of that product that is being created? And so kind of the pretty broad spectrum on what we cover within that. Oh, yeah, sorry. Okay, so, not too far. Thank you. So the project, just to give a flavor of kind of some of the stuff that we're thinking about, is in the composite side of things. So this is effectively around machining of composites, carbon fiber parts, but primarily thinking about things like the aerospace industry, or maybe pressure vessels for hydrogen would be another good use case. And looking at how we can improve the quality of that part when we're machining it, when we're removing material from it. There's an awful lot of work that has been done in the metallic space to try and get information while we machine out a part, so that we can see if we're doing, basically if it's highly accurate, if we're producing a good quality part. And that you kind of take as much sensor information, as much SPC data as you can, and automatically update what you're doing on that machine to make it more accurate in real time. And it's still an exploring space, but it's definitely farther along the line than it is in the composites world. Composites world is really where this is focused. So what we're trying to do here is really make sure that we're making the part we said we were going to make. We're doing it to a higher accuracy and a high tolerance, which means that we don't scrap as many parts. We don't result in us having defects that we have to then do concessions on, and we might have to do rework on. But basically, it's trying to move us towards the right first time manufacture in a very simplistic way. This piece of work is around working with the machine tool makers, machine tool providers, to be able to use the brains of the machines that they use for, or their machines that we use for that subtractive machining component, and being able to feed in additional sensor information back into the computing and the PLC that's running that machining process, and be able to update the parameters of that machine in real time and be able to optimize that for specific types of composite. That's really where the focus is. The actual work would be involved in understanding what are the key parameters that we need to measure, what key sensors do we need to put in there, being able to do machining trials on specific types of composite. So we think there's interest specifically around kind of tubular designs because they're very analogous to, as I said, pressure vessels, but also an awful lot of different other parts within an awful lot of the industries that we look at. Going through some machining trials. Oh, I've been speaking for ages. I need to be faster. I'm just talking about stuff. So fundamentally, the aim would be to do trials on that to try and then feed that information back in. And then that is leading towards us having better machine tools in the future that are specifically useful in this composite space. So far, we've kind of approached, I'll probably a slide off, so we're waiting until that catches up. Yeah, I suppose the impacts that we're looking at are around us improving the machining centers themselves. So the machines, we want to improve those designs and work with the machine manufacturers to do that. There's potentially new IP to be generated in the machine learning and AI spaces, because that sensor data is going to have to, we're imagining, isn't going to be sufficiently valuable by using normal statistical models. So when we bring in that AI element, can those models themselves be expanded and productized out themselves and used and translated across to other areas? Obviously a reduction in the environmental impact from a wastage point of view, and then a higher quality part. We're probably at the lower end of what the smart funding is allocating with respect to timeframes. It's about a 2-year project, we would estimate. I'm sorry, I've done it again. Get used to this eventually. And then the last couple of bits are, we've approached Doosan in as the machine manufacturer about this previously, and they've been interested in that, so we want to re-engage with them on this. And there's a couple of smaller SME size organizations in the UK, more local to our area, who are interested in adopting some of this technology as well. So we've got someone in that, but we're very much interested in seeing if there's other machine tool makers out there who would be interested in getting involved, and if there's any other use cases of people in that composite space that might want to get involved with us as well. Yeah. Yeah, so fundamentally, you're onto one of my favorite topics, because I talk about legacy machines all the time. My expectation is with this project that we probably won't be going too heavily into legacy work. I think this is still early on enough in its research side where the market opportunities around trying to look at new product at the moment. I think we'd probably, 3-4 years time, start looking at how we can look at retrofit and legacy side of things. I just being honest about where we are, I think. It's only one slide, so it's grand. That was just a bit of me going, yeah, that's one project that we have. Yeah. The focus for this will be around 3 or 5 axis milling machines, or more standard machining. Yeah, again, it's a kind of, where do we go next? We've got some decent capability with robotic machining ourselves, and there's a logical way that we can move forward with that, but there's not a huge amount of robotic composite machining going on at the moment, and I would say it's definitely lower on the TRL scales than what we're looking for here, if that answers the question. But in an outside of Eureka situation, that would definitely be a conversation we'd be very happy to have. Last bit for me was just going, look, that was just one idea. There's loads of stuff going on at the moment, and we've got a fair bit of capability in a number of areas. So from previous, there was one of the presentations around some of the additive stuff that I think we're going to try and jump in and talk a little bit more on. We've got standalone and non-standalone 5G capability, which is we're trying to work out how best to take that forward with research at the moment. So if anyone's interested in that area, let us know. Massive stuff around human-centric design and how humans come into these processes. I think earlier on there was a presentation or pitch around kind of the robotic emulation of humans and that side of things, which is a really interesting area for us. And I've been up here too long, so I won't talk through all the rest of them. But just if there is anything on there that's of interest, let's have a chat.